What is async and await? Let's take a look. Well, as a consequence of making use of a new mechanism in order to add asynchronous mechanisms to Python, we introduced a bunch of new syntax in Python 3.6, and new syntax has been coming in every subsequent version as well. At its core, we have the async def syntax. Here, this is a function that when you call it, returns an asynchronous coroutine task that can then be scheduled to run. And the way that you can schedule this, the simplest way to schedule this thing is to just call this run method. Now you can think, and you might wonder, is this run written in pure Python? It might be, but eventually somewhere this has to call into an event loop. And so if we dig through this thing, we might not see that much C code, but we're going to eventually see it hit an event loop, or we're going to see some large event loop, some scheduler that's scheduling everything that's passed into it. This run is our entry point for our asynchronous program. One of the tricky things about async IO is when we run this entity, we are saying you're running it in the context of an asynchronous event loop. It can then decide that it wants to trigger the running of something else in the contents of that same asynchronous event loop. So here, let's add a couple of print statements here. This is G, and here's F. And you can see we ran F, and that triggered the running of G. Now, if we do 3 of these in a row, it's serialized. This is really no different than if these were just regular functions like that. And these are run completely deterministically. And if we were to do some additional work in between, we know that all of this work up to this await is done without anything possibly interleaving it. So we know all of this work here is atomic. Any piece of work here is also atomic. Now, that by itself doesn't seem altogether that useful. It's like, okay, it's just like a normal program. I'm running F and it's calling G and it's calling G again. Well, it turns out that sometimes we want to run multiple things and we want them to interleave in certain ways. And so async IO provides us with primitives for performing that interleaving. The simplest primitive is gather. What gather does is it takes multiple asynchronous tasks and it says, you know what? I'm going to schedule them all so that they can run in an interleave fashion, run simultaneously. And here we can see a simple program that launches us into our entry point. And then in that entry point launches at each one of these. Now let's give each one of these things a name, just so we can see this very clearly. So here we'll give that 1, 2, 3, 4, 5, 6, and 7, 8, 9. And to show you that these things will actually run in that fashion, let's have them sleep for a random amount of time. And this is a conceit that we'll use a couple of times, a random sleep, just to show that any one of these can run at any point in time. These are actually interleaved, and let's await that. So you can see, there we go. It's 1, 2, 3, 4, 5, 6, 7, 8, 9, or it could be 1, 2, 3, 7, 8, 9, 4, 5, 6. Well, if these things return some data, we get that data back from gather, and we get it in a list that is guaranteed to preserve the ordering of these results. So even if they run in some non 1, 2, 3, 4, 5, 6, 7, 8, 9 order, the results that we get back matches that additional order. So we could, of course, do something like this, for X in inputs, put this into we'll have to unpack it like that. And if we wanted to tie our inputs to our outputs, we might end up having to do something like this. Inputs, outputs, and then put this into, say, a dictionary so that we can see which input corresponded to which output. But you can see they all get to run whenever they want to run. Now, this by itself is also not that interesting. Now you can think that this AIO sleep is here sitting in as a stand-in for some operation that is mostly waiting. When we're sleeping, there's really nothing more that we do than wait. We wait to wake up. But this could be a stand-in for a database connection, a connection to a remote device over SSH, even working with a file. This could be a stand-in for any of those operations. This is one of our primitives. Now we'll talk about another primitive, the task group, that takes this idea of gathering and adds one additional important aspect to it, but this is the core of what we have when we're dealing with Asyncio. Here's the tricky thing. If I'm going to write a program making use of Asyncio, well, I'm going to have to launch into my event loop. So I'll launch into my event loop with that run. And in this event loop, I'm going to call some other function, and maybe this is just a regular synchronous function, just a regular old function. I'm going to call another unit of computation, and this thing is going to be another just regular function, and everything is fine. Now, let's say that the thing that I'm waiting on here is an HTTP request. And so what I might need is like an HTTP library. So what we'll do is we'll make use of HTTPX for this. So let's get HTTPX installed. And here we could say, from HTTPX import async client. And here we might say, okay, here what I want to do in each of these is I want to make a web request. So I want to use an asynchronous client like that. And then I want to do a client.get. And here I'll do this on some URL. So this will load for some URL here. And I guess G is more or less the same thing. Or maybe G does something else. So maybe here I have from AIO SQLite connect. Maybe this connects to an SQLite database asynchronously. And it does some operation like, like this. And here we'll do this on a memory piece. Well, if I want this to be interleaved, I need to mark this as being interleaved, so I need to make that awaitable. And if I need that to be the case, then I need this connection to also be asynchronous. So this thing also needs to be an asynchronous with. And it turns out that when I'm using Asyncio, it's oftentimes the case that I can't just take an existing program and move it to Asyncio without making significant and substantial changes. For those of you who have familiarity with threading, you would have experienced the case where you can take a program that has no notion of threading, and you can carve out small domains of that program, run them in separate threads, and you don't need to change the entirety of the rest of the program. When it comes to Asyncio, you'll often see this behavior where one tiny change in one place kind of creeps and creeps and creeps and creeps up until the entire program needs to be async aware. And when we look at all the syntax that were provided in Asyncio, the async with, the async context managers, the async for, all of this really comes down to, at some point, if you need to interact with that event loop, you need to be doing that from code that is aware of that event loop. In the absolute core of it, in Asyncio, you can only go from being scheduling aware to being scheduling aware, being aware that there's something that's going to schedule you. You can go from being scheduling aware to being scheduling ignorant. You can forget that something is scheduling you and just leave it up to the serial nature of the program. You can go from being scheduling ignorant to remaining ignorant, but you cannot go from being scheduling ignorant to being scheduling aware without finding some out-of-band mechanism to reintroduce the idea of a scheduler. This is typically, and here you can't do this, this is typically what people call the function coloring problem. What they'll say is they'll say that synchronous functions are one color and asynchronous functions are another color. And if we think about synchronous functions as being this color red and asynchronous functions as being blue, you can say, oh, in here, you can call a red-colored function, but you can't call a blue-colored function. Whereas in here, you can call a red-colored function or you can call a blue-colored function, and that asymmetry. But setting aside all of that, a lot of languages say things like, oh, we don't have function coloring, and they're all wrong. Fundamentally, you can only go from being aware of a scheduler to being either aware or ignorant of the scheduler. You can't create knowledge of the scheduler. Languages which claim to not have function coloring, what they're actually doing behind the scenes is they're saying, usually what they're saying is there's one singular event loop that's language defined, and as a consequence of that, when you're going from ignorant code to aware code, they're just finding some out-of-band means to throw that scheduler back in, to sneak that scheduler back in. In Python, as a consequence of all of these mechanisms evolving over time, and there being parallel implementations of that scheduler. Historically, there have been tools like Trio, Curio, and Asyncio in the standard library, as well as many tools that predate the Python 3.6 introduction of all of this vocabulary. As a consequence of that, there is no one singular scheduler that everybody agrees on, and so you can't really go from being scheduling ignorant to scheduling aware. You can't just reintroduce that without some dirty hacks like, going here and getting the event loop and then scheduling without that event loop. I'll show you what this means in consequence. Let's go to our SQLite example. And we'll make use of a special module, a third-party module, that gives us SQLite support in an asynchronous context. One of the things that you'll notice when you use asynchronous programming in Python is you end up having to import a lot of things that are outside of the standard library, in part because the standard library's support for asynchronous mechanisms is not thorough throughout everything that we historically would want to do, like connect to a database or make an HTTP connection. And only third-party tools provide you with that asynchronous support. So you'll see that in our code, we might end up using things like AIO files in order to asynchronously open a file, AIO SQLite to asynchronously create an SQLite connection, whatever the case may be. Well, here, let's create a simple asyncio program. We'll launch into our entry point. And in our entry point, we'll create a connection to an in-memory database using SQLite. And this is typically how we do this synchronously. We do something like this, and then con.execute. Let's execute something simple like a select one. And that gets us a result, and we print out the result. And I'll swap this out with our standard SQLite 3, just to show you. That's kind of what works. Here, let's get the result from this. Let's unpack that. There we go. But when we switch this over to our asynchronous land, everything breaks. And the reason for that is, well, the whole purpose of making this asynchronous is for this to be scheduled, and to be scheduled alongside, maybe we have multiple different things that we're doing with this database. So maybe this is task 1 is to do the select one, and task 2 is to do another operation. And just as a stand-in, we'll do a select 2. And I'm going to gather these and get my results like that. And so here I get all of my results, and here this is going to be a little tricky. So here, these both need to be the asynchronous tasks that need to be awaited. And the moment all of this becomes asynchronous, that needs to be asynchronous as well. And this needs to be task 1 and task 2. That's good. And then finally, here we need our gather. There we go. And then we get each one of our cursors. And then here we'll unpack the results for the results in our cursors. There we go. And this should be each one of the individual cursors. And then here we're going to have to fetch. Let's fetch many from this. And then here we're going to have to await that. And then finally, we get our results. So you can see we have this behavior where everything needs to be asynchronous. Well, to give you a quick summary of all of the syntax we have asynchronous tasks, representing one computation that itself may have some portion where it interleaves, where it needs to await something, or where it needs to dispatch eventually to something else that needs to await something. If the thing that we're waiting for has some context associated with it, and that context is asynchronous, like say this is not just some function, but a setup action, and there's an asynchronous teardown action. And we want to join these together in some kind of context manager protocol, like that, and await them. And we want to yield in between. Well, we can't make this a regular context manager because this thing can't await anything, because this is asynchronous unaware. It's scheduling ignorant. So that has to be an asynchronous task. Instead of importing context manager from context lib, we have to import async context manager from context lib. And when we use this, we can't just with our context, because this will trigger code that is scheduling ignorant. So we need to make sure that this triggers code that is scheduling aware. So we need to do an async with to make this all fit together. And what you can think is any time you write some code, and that code could eventually lead to some other code, and that could then eventually lead to some other code, that could eventually lead to some other code, that could eventually lead to some other code, that could eventually need to allow itself to be interleaved asynchronously, everything up that chain needs to be async aware. Now, in this particular case, here I'll put prints for my setup and my teardown. You can see it was these two terminal points that we're saying are going to do something asynchronous. Maybe they're going to make a network connection, whatever the case may be. But largely, from a syntax perspective, this is why we have async with. It's because a context manager may need somewhere inside of it something that needs to be done that needs to be asynchronous. The other syntax we have, in addition to the async def and the async with, is the async for. What if it's the case that we have some data retrieval or some data processing, and this data processing needs to interact with our database? Well, if it needs to interact with our database, if it didn't need to interact with our database, we'd write this just as a regular generator. But if it needed to interact with our database, then we have to make that asynchronous so it can interact with our database. And if it needs to interact with our database, for example, it needs to go through each one of these elements and then yield out what happens when we select. Here, let's do a select like this. Hopefully that syntax works. And here, we have to do like that. Let's get our entry point. There we go. Well, here, we're going to try and process each one of these operations. If we try and do a for loop like that, this for loop is going to trigger code that itself needs to be scheduler aware. And that's not going to work. You're going to see that in this case, and let's run this. See, in this case, we get into trouble. And the reason we get into trouble is this for loop behind the scenes, remember, is calling next on some iterable, which is calling next like that. This is not async aware, which means nothing inside this thing can be async aware, which means we've lost knowledge of our scheduler and we fell out of this asynchronous behavior. And so as a consequence, we need to make this an async for. Now let's pull in our connect. Let's see if our parameter here, this should be execute, not select. And then finally, let's parenthesize this like that. Actually, no, this is you con.execute to get the cursor. All of these libraries, and then you await the cursor to get the result. Actually, let's do this for like that, and we'll yield out each one of these results. That should work. And then finally, this thing needs to be awaited. And then finally, we have one more problem here, which is this thing here. I'm going to just do something I really shouldn't do, but just to get this to go, we'll skip our use of prepared statements. And here we can see our results here. And let's bring back our prepared statement. So I think it's like this. Oh, that's a real shame. Maybe we can do this with that style. And here we have to just, okay, so I don't know the prepared statement. Maybe it's always something different. It's like every one of these stupid tools decides it wants to do prepared statements very slightly differently. So let's see if we can get, is it like that? Nope. Well, this is dependent on us figuring out how to do prepared statements in AIO SQLite, but it's one of the 15 different possible ways to specify it. Thankfully, none of the tools do it exactly the same, and they all choose their own nutty way to do this. But I think we get the general idea. This is why we have so much additional mechanism of vocabulary in Python, because once one thing needs to be asynchronous, everything leading up to it needs to be asynchronous. So I want to draw this to a conclusion. I want to share with you one of the key points. Generally, async IO cannot be added to a program after the fact as easily as threading. In general, if you have a program and it already exists and it's already fairly large, you're probably better off trying to slip in a little bit of threading to deal with any problems you have with the lack of concurrency, rather than trying to get this to be async IO aware. Because when you're writing async IO code, you really need to start day one thinking about everything async IO. Also, once some portion of the code needs to be scheduler aware, everything leading up to it also needs to be scheduler aware. Otherwise, you've lost knowledge that this is code that is scheduled. You've lost knowledge that this is code that is structured in some fashion. And only with some very dirty hacks can you reintroduce that knowledge, can you actually re-enter that event loop. In general, the only syntax in Python for async that you really need to know is async def. And this is a function that will call something asynchronous. Async for, and this is an iterable that will eventually call something asynchronous. Async with, this is a context manager that will eventually call something asynchronous. And all of the consequences of all of these, like using async context manager instead of context manager from context lib, everything consequential from this. But these are the only three parts. Of course, there's await, but there's only one await, and this means call something asynchronous and have it scheduled.